How many do we have here? Well, it looks like it goes to something else. In fact, I think we might have done 22 also. Yeah, we did do 22 because our domain expanded from 0 to 2 pi to what?
Just so the answer was 6. It went to
right. I know
6.
It went from 0 to 6 pi. Okay. And we even did number 1. And we did number 2a and 2b. And we stopped after that. Ran out of time. Okay. First of all, I need to expand that a little bit. Do that. Take a screenshot of it. And make sure that I'm, oh no, I can't do that anymore. All right. So all three of these problems are basically the same. What is the first step in part C?
Find the angle, or?
Yeah, well, it's recognize that that is an angle. And by that, I don't mean 2 sine, I mean that. The inverse sine of a number is an angle. So the problem really is the cosine of 2 theta. So, next step. What is the, whenever I say next step, what's the most likely answer? Draw the triangle and do what?
Solve for theta.
Label theta. Not solve for theta necessarily. Label theta. You have to label theta because I got 2 choices for theta. I got this angle up here, and I got this angle down here. So if I don't label theta, I can't even begin the discussion after that. In other words, I've got to label which one is theta so that I can dimension this triangle. That's the key. If I now know that the inverse sine of y is equal to theta, that's why I label that theta. In fact, this is probably the way I should always teach it, is that the inverse sine of y is equal to some angle. We're going to draw a triangle and label that angle. Now, dimension that. It's always the third step. Okay,
So the opposite y and the hypotenuse.
Good. What else is what?
The hypotenuse is 1.
What's the third side?
The square root of 1 minus y squared.
Good. There you go. That's how you solve a right triangle quickly. Okay, now, we know what theta is, or in terms of y, but we don't know what cosine of 2 theta is. So let's talk about the identity. What is the cosine of 2 theta equal to? There's 3 of them. You probably only need 1.
It doesn't equal. It's like sine minus 1, or 1. It's 1 plus sine.
Minus, it's always minus. All 3 of these identities are subtraction. And it's 1 minus sine squared of theta. So that's what cosine of 2 theta is equal to. Well, now we have a triangle to figure out what sine squared of theta is. So what is it? 1 minus 2 times, what is the sine of theta? And we're going to square it. Excuse me. Yeah, no, that's right. What's the sine of theta?
Y.
So our answer is 1 what?
Minus 2y squared.
All right. The 2 is not squared also. So there you go. That's what the answer is. All right. That's good. You're getting it, I can tell. Okay. Classic trig problem. They give you one trig function, and they tell you which quadrant it's in. And then they're going to ask you about other trig functions and double angle trig functions. So, what's our first step here? To the classic trig problem. If a person could only ask one trig problem to a student of trigonometry, this would be it. Not necessarily part B, but part A. You have to be able to do this. What's the first step? It's the most likely first step.
Draw the triangle.
And
determine if it's positive or negative.
no.
Oh, label the
Triangle is not enough. Drawing a right triangle, first of all, has to be a right triangle. If I don't do anything more, I can't go any further.
You have to label it?
Label A or alpha. So I'm going to call alpha that. I could have called alpha this up one up here. It wouldn't have mattered. Everything would have been the same. But I got to label alpha so that I can dimension the triangle. If I don't put an angle on there, there's no way to dimension the triangle. So now dimension it for me. Ignore the sign for a moment. On all of these problems, you need to ignore the sign and treat it like it's in the first quadrant. That's the secret for doing these.
So it'd be the opposite step and adjacent to 3.
Yeah. In other words, we're ignoring that negative sign. We'll get to that, but not yet. Now tell me the hypotenuse.
What, 58? Or not, square root of 58.
Good. Now tell me the cosine of A with an exact answer.
Three over square root of 58.
Now, what's the sign on that? Is it a plus or a minus? It's always my last step. I always go in exactly the same sequence every time. And I leave the sign to the end because it just kind of gets in the way. If you pay attention to that negative sign or quadrant 2 before you draw this triangle and get your answer, it just gets in the way. Now we have to put a plus or minus sign on it. What is it?
It's a minus sign.
Does that agree with the tangent being negative?
Yeah.
Yeah, they're both in quadrant 2. So it does indeed. Okay, now we've got the cosine of 2. Notice we never figured out what alpha was. We never bothered to, wasn't necessary to. I was still able to figure out the cosine of alpha without knowing alpha. That's the beauty, and that's why this is such a great question for trig, is you don't figure out alpha. You might think you'd use your calculator here to figure out alpha and then figure out the cosine of alpha, but that's not the way your teacher wants you to do it, and that's why they say give an exact answer, not a decimal answer. A decimal answer would not work, and yet that's what you would get out of your calculator. You'd get a decimal. So this question is very definitely designed to be done without a calculator. You have to use this technique. Now, give me one identity for the cosine of 2 alpha. It's not going to matter which one, because I'm looking at the triangle. I can figure out sines, cosines, tangents, anything I want, as long as I got an angle and I've got all 3 sides dimensioned. So just give me any identity you know. What was the last problem? We used the same identity. Which one? What was it?
Between the sum and difference one?
There's 3 identities. We just did problem number 2 using an identity for cosine of 2 theta. Which one did we use?
Sine.
Give me the whole identity. It's not sine. It's 1 minus 2 sine squared. That's the identity. When you're doing a double angle, that's one of the 3 identities. And the reason that's all we need is because we can go over here and look at this triangle and figure out what sine of alpha squared is easily. So what is it?
It'd be 7 over square root of 58.
Sine squared. Okay, so 7 over square root of 58. And I gotta square that. So what does that equal to?
49 over square root of 58.
Nope. Square root of 58 squared is 58. Square root of 7 squared is 7. Square root of 19 squared is 19. Square root of x squared is x. So it's 49 over 58. Now, let's see, what best way to simplify that? And certainly cancel that and make that 29. So now I got 1 minus 49 29ths, which means 29 29ths minus 49 29ths gives me negative 20 29ths. So that should be my answer with the proper plus or minus sign. Minus 20 29ths. We have an answer sheet on this, don't
we? Yeah.
3B. We're on the free response, I believe, aren't we? No?
Yeah, but
yeah, we are. I got to go all the way. Yeah, I got to scroll way down here. It's test 4 free response. 3B, minus 20 29ths. All right. Whoops. Minimize that. And I want to, looks like this only allows you to open one thing at a time. this, I got a, it's not Microsoft, yeah, Microsoft Office clone that makes me put up with ads. But better than paying $500 for Microsoft Office. What the heck happened here? I clicked on the wrong thing here. I clicked on an ad. Brief, hold on. I don't know. Here we go. And I tell you what, they do not make this very user-friendly. They really do not. Unbelievable. Notice how this thing on the right covers up my scroll bar?
Mm-hmm.
I can't scroll down. And now if I grab it, Jesus. Hold on. Let me figure this out. First of all, what do I have open? Just those two. Okay, so I should be able to click on your test for review. And I should be able to find where we were at. There. That's what I was trying to do, is get rid of that, because I couldn't get access to the scroll bar. So we just did 3B. When you are simplifying trig functions and you don't know what to do, try turning everything into sines and cosines. Okay?
Okay.
That's the best answer I can give you. It isn't always the correct answer, but it will save you on a lot of occasions. Turning everything you see, especially when you see stuff that can easily be turned into sines and cosines. So if I turn everything into sines and cosines, what do I get? That's already cosine. What's tangent of theta become?
Sine over cosine.
And cotangent of theta?
Cosine over sine.
Now, before we go to the trouble to find a common denominator and add those two terms, might be better to just multiply the cosine of theta and see what we get. Because the first term turns out to just be sine. The next term turns out to be cosine squared over sine. Now what? You have to know your algebra pretty good in order to do trig expression simplification. How do I add these two things?
Multiply by sine over cosine.
Nope. How do I add these two things? This is not an equation. This is an expression. Look,
need a like
simplify
denominator.
that. When you add anything, if one of them is a fraction, then you have to find a least common denominator. That is always the answer. And for some reason, it really escapes people. If I told you add 2/3 to 3/4, you would immediately say find a least common denominator, correct?
Yep.
But if I told you to add 1 plus 7/4, it would stump you. It shouldn't. You still have to find a least common denominator. And it's the same thing in trig. It does not matter that 1 does not have any denominator. It does have a denominator. It's called 1. So if I were to put a 1 under here, now what's the least common denominator? When I add, what is the least common denominator?
Sine, sine.
Sine of theta. So I always write it like this because I think it works better. Now, what should go in my top left numerator?
Sine squared theta.
Yeah, exactly. Now you can see what's going to happen. This is still cosine squared theta. So what I end up with is sine squared theta plus cosine squared theta all over sine theta. What does that become? What's sine squared theta plus cosine squared theta?
1.
Okay, so now we have 1 over sine theta, but in trig, they would prefer you to have an irrational denominator than a trig function as a denominator. So that is not fully simplified. What does that equal to?
Cosecant theta.
Yeah, they want your answer in the numerator. In other words, you would lose probably a point if you gave 1 over sine theta as an answer to this problem. If you ever see an answer where you have a trig function in the denominator, then use its reciprocal to put it into the numerator. Always. Now, my last suggestion was if you don't know what to do, convert everything into sines and cosines, which is exactly what we did on A. Well, this is already everything in sines and cosines. So what am I going to do here?
Just solve for it.
Tell me what to do. Don't tell me solve it. I know that's the answer. I want to know what the solution is.
You could look for identities, I guess.
No, no, no. It's already in sines and cosines. Again, you're adding one fraction to another. This is not a solution you like because you constantly get stumped on it. When I'm adding two fractions, what do I have to do?
Get a common denominator.
Oh. So what's my common denominator?
Cosine t times 1 minus sine t.
And do not multiply that out. Leave it like that for the moment. Sometimes you'll have to multiply it out, but most of the times you won't. You'll see magical cancellations. Now, what goes in the upper left?
It'd just be the opposite flipped on the top. So it'd be like cosine times sine, or cosine times 1 minus sine on the left, and then on the right it'd be.
What we have to do is make that be exactly the same with whatever we end up with that. So I know you know how to do this. Think about it for a second. What do I need in the top so that that statement would be true?
1 minus sine squared t.
Yeah, almost. 1 minus sine t, all of it squared. Notice that one of those is going to be canceled out by the thing in the bottom, and I'm going to be left with 1 minus sine t over cosine t. And that's our goal, is to not change that fraction. Whenever you're finding common denominators, it doesn't even have to be a least common denominator. Just you're finding a common denominator, then just know that your goal is to not change the fraction. That's why I do them the way I do them, where I figured out the common denominator first, I write it in both fractions, and then I figure out the numerators. So what's the numerator on the right have to be?
Cosine t squared.
Cosine squared of t, and there is a difference. Cosine, well, let's just talk about that for a moment. You got this, you got this, and you got this. Which of those two are the same?
Top and bottom.
Yes. And the middle one is not the same at all. In the middle one, we square t first, and then we take the cosine of whatever that angle is. But the top and bottom do mean the same thing. And so that's why it was important. When you said cosine of t squared, it depends on whether you put the parentheses around it. If you don't put the parentheses around it, that's the wrong answer. Put the parentheses around it, then it would be okay. All right, now, once you have added fractions and gone to all the trouble to find the least common denominator, the next step is always to operate on the numerator. Well, what's the numerator become? Now I need more room to write. I can't do it over there. What do we have to do to the left side? Dealing with the numerator only for the moment. Kind of like when you have two fractions. When you have two fractions that are being added or subtracted, you always have to find a common denominator. When you have something that's being squared in the numerator, you generally have to operate. You have to do that, square that. What do you get when you square it? Square 1 minus sine of t.
1 minus sine t squared.
Nope. Foil it. One minus sine t times 1 minus sine t. What do you get when you do that? You don't get 1 minus sine squared of t. That is the most common mistake in algebra.
It'd be 1 minus sine t, or 2 sine t, plus sine squared t.
Okay, that's what we get. So we got 1 minus 2 sine t plus sine squared t plus cosine squared t. Right? That's the entire numerator, and our denominator hasn't changed. We're not going to distribute it. The general rule of thumb is you never distribute in the denominator, but you kind of have to distribute in the numerator because the numerator is what you're operating on once you've found a common denominator. Now, what does the numerator become? What's that?
It'd be 2 sine t.
What is sine squared t plus cosine squared t equal to?
1.
Okay, so now we got 1 minus 2 sine t plus 1. What does that become?
2 minus 2 sine t.
Factor that. What does that become?
2 times 1 minus sine t.
So I can erase this entire numerator and replace it with 2 times 1 minus sine t Now what can I do? That's a magical step there. By magical, I mean it's much better than if this said 1 plus sine t. or 2 minus sine t. The fact that it says exactly 1 minus sine t, I got that in the numerator, and I also have it in the denominator.
So just 2 cosine t.
It's 2 over cosine t. And again, let's not leave trig functions in the denominator. In trig, kind of the equivalent of rationalization is this step here. In other words, you generally don't want irrational numbers in your denominator, and you generally don't want trig functions in your denominator. So final answer, that's not a good answer. It's got a trig function in the denominator. Let's get it out of the denominator.
2 secant t.
There you go. And that's the answer. All of these are going to come down to a single trig function like that. Now, you know the rule I said about converting everything to sines and cosines? You don't use that rule if you're looking at a bunch of tangent squareds and secant squareds, because we have Pythagorean identities for those. Tell me the Pythagorean identity for tangent squared. What is it?
1 minus secant squared.
Give it to me in the normal way. That's the identity. That's the only thing I want you to memorize. Now, you can algebraically manipulate that to get 1 minus secant squared. What would it give you? What would 1 minus secant squared be?
Tangent squared theta.
Not tangent. I got to move the tangent square to the right, so I got to change its sign. That's what it's equal to. In other words, I move the secant squared to the left, I move the tangent squared to the right. This is what I get. That means I can replace that with negative tan squared of w. So now that becomes a much simpler problem. Everything is in tan. What do I do now?
So it's just negative tan w.
Oh, hold on. Let me rewrite it just so you're not misunderstanding this. This is a very simple algebra problem, and it's strictly algebra. How do I simplify that?
It's 1 over tangent.
Hold on. The best way to simplify it when you have a single denominator is to split it into two fractions. You got that fraction plus or minus that fraction. So what's the first fraction?
Negative 1.
What's the next fraction?
The 1 over tangent w.
Okay, and it's plus. In other words, the two minus signs turn into a plus. Okay, now what's 1 over tangent w?
Cotangent.
So our answer is cotangent w minus 1. Or minus 1 plus cotangent w. Whenever the leading term has a negative sign, I'm always tempted to switch the two terms just because it looks nicer. If you had a multiple choice, I would say this would be on your multiple choice. Probably not that. But it could be either one. Okay? So, let's talk about this just a little bit more. What is a plus b over c? equal to?
A over C plus B over C.
What is A over B plus C equal to?
A over B plus A over C.
Trick question. No. You can only split it into two fractions if you have a single term in the denominator. Notice that if I did split it into that, it would not be equal to what I'm looking at. I would have to find a common denominator, which would be BC. That would be BC. This would have to be AC. This would have to be AB. I would add them together. I would get AC plus AB over BC. And that is not A over C plus B over C. So always remember, you cannot do this second step. Ever. You can only do it if you have it in this situation. And it's fine if I have A plus B plus C over D. I can split that into three fractions just fine. But if I add another term to it, then I'm dead. I cannot simplify that. I can't do anything with it. Well, I guess I could say that's equal to A over D plus E plus B over D plus E plus C over D plus E. Just to be clear, you can do that. As long as you treat that as a single entity, you can do it. You understand the difference, though? It's a little complicated. I probably shouldn't have even showed you that because you're never going to have to deal with that. Let's go on. So I don't want to mess you up. Sometimes different approaches are helpful. Sometimes they're hurtful in math. Sometimes they just serve to confuse. I don't want to do that. Okay, what do I do on A? I'm trying to solve for Y.
Well, you know Y's in there.
Looking at that one right there. If you're trying to solve for Y, start isolating.
So you divide both sides by square root of 2.
So now we have this. Now what? Trying to solve for Y. When you're solving for an angle, you take trig functions of angles to get ratios. You take inverse trig functions of ratios to get angles. So what is Y equal to?
Inverse cosine of 1 or negative 1 over.
Not drop negative signs. It's negative 1 over root 2. Now I don't care if that's an irrational denominator, because my point here is to figure out what this angle is. So where does that occur? First of all, what's the angle? Ignore the negative 1 first. This negative 1. This negative 1 that I'm pointing at. Where is the cosine equal to 1 over root 2? Always look to your basic two triangles. These two triangles are probably more important in trig than geometry. This is a 45-45 whose measurements are 1, 1, square root of 2, This is a 3060 whose measurements are 1, root 3, and 2. So now let me ask again, what angle is the cosine equal to 1 over root 2?
45.
Okay. However, that is negative 1 over root 2. So I got to find the two quadrants where cosine is negative. Where are they?
The second and third.
Okay. What is the equivalent angle to 45 degrees only in the second quadrant?
135.
What is the equivalent to 45 degrees only in the third quadrant?
165.
Third quadrant. It's got to be greater than 180.
Oh, other way. 265.
225. Let's just review our unit circle. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus, but one of the most important things about these quadrants is that when you're converting them to first quadrant angles, you got to know that it's 180 minus theta in the second, and it's theta minus 180 in the first, or in the third. So if my angle is 45 degrees, that's theta. So the equivalent in the second would be 135. And if my angle is 225, that's the equivalent in the third of 45 degrees. In other words, you always take 180 plus that first quadrant in the third to figure out the angle. In both of these cases, theta, I see why I'm confusing you. But I shouldn't. I think you understand the unit circle enough to know why these are the two answers. First of all, if I said to you, what is the cosine of 135 degrees, what would you do? Do that manually, not in your calculator. What's that the same as? You would substitute 135 for theta, you would subtract it from 180, and you get 45. Okay? Only it's negative. So if the cosine of 135 is the same as the cosine of 45, which is 1 over root 2, but we're in the second quadrant, so it has to be negative. Now if I said to you, what is the cosine of 225? The 225 goes in for theta, and that's the same as the cosine of 45, which is still 1 over root 2, and it's in the third quadrant, so it's also negative. So both the cosine of 225 and the cosine of 135 are negative 1 over root 2. So all you kind of do is working backwards here. And it's a little bit difficult, but not really. If you really understand this unit circle and you understand that and this. And then in the fourth quadrant, it's 360 minus theta. In other words, everything you see over here, you should have memorized. Everything. 1, 2, 3, 4, the ASTC, and these three formulas for how you convert a second quadrant angle into a first quadrant angle. It's just in this case, we're trying to convert a first quadrant angle into a second and a third. So you kind of have to go in reverse here. Now, the reason I did second and third was because this said that y was between 0 and 2 pi. So you have to cover the entire unit circle. And furthermore, if you were to try to do this in your calculator, you would not get the right answer. You would do this, and then you would do this, and you would get an answer that was second quadrant only. It would never tell you the third quadrant answer, because calculators don't do that. Calculators don't put the entire unit circle in there. They give you one quadrant for positive cosines and another quadrant for negative. Now with cosine, it's the first quadrant for positive, it's the second quadrant for negative. They're never going to give you the third quadrant on your calculator. So it's really important that you understand that diagram of the unit circle so you can figure out how to figure out the third quadrant. Now, once you've figured out the third quadrant is 225, well, now your calculator will give you the cosine of 225 as -1 over root 2, or the equivalent decimal. Probably won't give you -1 over root 2, but it'll give you a decimal that's the same thing, almost as. So don't think you can solve a lot of these problems with the calculator. They're not going to do it. It'll give you one of the answers, but only one. All right. These are algebra up to a point. Well, hold on. How are we going to solve B? Any idea?
No.
One of the reasons that you have to memorize your trig identities and you can't refer to a piece of paper is this. If you have to look at a piece of paper every time, you're not going to be able to go backwards. If you have it memorized in your head, you are going to be able to go backwards.
Well,
what is S equal to? That is a trig identity. What is its expression normally? What's another way to write that?
Sine 2 theta.
There you go. And you can only do that if you have it memorized. I don't think you can do it if you have to look at a piece of paper to see all these identities. Possibly you can. I guess you can look down the right side of each identity and see if you find 2 sine theta cosine theta. But that's not what most people would do. The average person, if they didn't know this identity, they would divide both sides by 2, and then they'd be lost in the woods. Okay. Now, remember our interval is for theta. So this is one of those situations where we have a multiple of theta. So what domain are we really going to operate on? It's not 0 to 2 pi. What is it going to be?
Zero to 4 pi.
So let's solve this. First of all, what's the next step? By this, I mean this. What's the next step?
So it'd be negative or inverse sine of.
Start on the left.
Oh, divide both sides by 2.
No, you have the right idea. We have the trig function of an angle, 2 theta, is equal to this. So the way we solve for 2 theta is by taking the inverse sine of this ratio. So 2 theta, not theta, but 2 theta has to be equal to the inverse sine of root 3 over 2. And I have to give all answers. That means my first quadrant, my second quadrant, my fifth quadrant, and my sixth quadrant. Because I'm going out to 4 pi. I'm going 2 unit circles. Because the domain of 2 theta is 2 unit circles. It's 0 to 4 pi. So what is 2 theta going to be equal to starting first quadrant? What angle is the sine equal to root 3 over 2? In other words, don't use your calculator. Use your knowledge of the 30-60 triangle and the 45-45 right triangle.
It'd be 60 degrees.
Okay, so that's one answer. And that's in first quadrant. That's positive, so that's good. What's the next answer? Which is the next quadrant where sine is positive?
Well, do you have to divide by 2 or
Nope,
no?
not yet. Let's get all the answers for 2 theta, and then you'll see. This, trust me, this is the way to do it. You don't want to divide by 2 yet. We will. We're eventually going to solve for theta, but we want all the answers for 2 theta. In other words, treat that as a single angle for the moment.
So 150 degrees.
No, it's 120. Remember, in the second quadrant, it's 180 minus theta. Theta is 60. So 180 minus 60 is 120. So if you put into your calculator either of these, if you said sine of 60, you get root 3 over 2. If you said sine of 120, you get root 3 over 2. So that's the first and second quadrant answers. Now what are the fifth and sixth quadrant answers?
240.
Nope, you got to add 360 to 1. Each one of these.
Oh, add 360.
Well, 1 unit circle is 360. So I've got my first unit circle answers here. That's the only 2 answers in the first unit circle. But remember, my domain goes out to 4 pi. That's 2 unit circles.
420.
And
480. Or no, yeah, 480.
yeah. Now we're going to solve for theta. In other words, we just got the 4 answers for 2 theta. What's theta going to be?
Just 30, 60, 210, 240. Yeah.
Notice all 4 of those are in the unit circle. So we do satisfy that domain right there for theta. But notice that if we do not expand the domain to 4 pi, we don't get those 2 answers. If we always think of 2 pi as being from 0 to 2 pi, or 2 theta as being in that domain, we're only going to get those 2 answers, which means we're only going to get those 2 answers, and we're going to miss 2 answers. So this step is extremely important about expanding the domain based on this number. If that number was a 3, then I would go out to 6 pi. If that number was a 14, I would go out to 28 pi. I would figure all my answers, and then I would divide by whatever that number was. It's the same pattern every time on this problem. All right, now we get, we got enough time to do this one, I think. When you see a squared in an equation, and you see a sine of t, a non-squared, same trig function, we are looking at a quadratic. It just doesn't look like a quadratic. If I wrote this, and I said solve for x, you would say, well, that's a quadratic. I'm going to put everything on one side, I'm going to put 0 on the other, and I'm going to solve for x. Trig, no different. Just because it's a trig function, treat it like it's a polynomial x. So I'm going to have 3 sine squared of t minus 2 sine t minus 1 equals 0. Now, how are we going to solve this quadratic? How do you solve quadratics in general?
Factor.
Okay. What goes first step of factoring? Tell you what, let me suggest something. When you say quadratic in trig functions, let me suggest you use substitution. We're going to let x equal sine of t. Always let it be that middle term. Now what we have is 3x squared minus 2x minus 1. And it's much more familiar looking, and probably you can factor it a lot easier. And once you're done factoring it, we're going to go back and resubstitute sine t for x. So factor this polynomial in x.
X minus...
Hold on, don't do it in one step like that. Do it the way I taught you. You split up the x squareds first.
Okay, so x.
No, x times x does not equal 3x squared. Remember that first term always comes from multiplying your first two terms. So what does it have to be?
3x.
Okay. That's splitting up the x's. Now what? It's the second step of factoring.
That's equal to minus 1.
No, you have to figure out both signs. I guess you and I haven't worked with factoring a lot. I have a certain technique that I teach people, and I believe my technique is the best. Now, I know they teach you a dozen different techniques through high school. I hate the California method. I hate the diamond method. I love my method. The second step is to determine both signs. They have to be opposite. The only way you can produce a minus 1 is if both signs are different. There's no other way to get a minus 1. If both signs are the same, that would be plus 1. If both signs have to be opposite. In this case, though, it could be plus minus, but minus plus is actually different. Sometimes plus minus is the same as minus plus. If the coefficient of the x terms is the same, then plus minus is all you have to write. I mean, plus in one side, minus in the other. But when that coefficient's different, you have to allow for both. Now, what are the factors of 1?
1.
Okay, so let's try 1 there and 1 there. Does that produce the proper middle term?
It can.
Does it?
No.
What middle term does it produce?
0.
No, the middle term comes from the O and the I of FOIL. And then adding those together. So that produces a middle term of plus 2x. Well, the fact that we got the right number, wrong sign, Means all we have to do is move that one down to there, and this one down to there. Now the middle sign will still be 2, but it'll be negative, because that'll be a negative 3x times a positive x. Add the two together, you get minus 2x. This is the correct solution. X minus 1 times 3x plus 1 equals 0. Real quick, I'm going to finish this out. We used x equal to sine t. So this really is sine t minus 1 times 3 sine t plus 1. That's what's equal to 0. Now solve that. It's a quadratic. You got two things multiplied together that equals 0. How do you solve it?
Set 1 equals 0.
Okay, so I got sine t minus 1 equals 0. Solve that.
Sine t equals plus 1.
Where does that occur? There's only one spot on the unit circle where that occurs.
The first quadrant.
What angle? They're asking you to solve for t.
90 degrees.
Yes. T equals 90 degrees. That's the only solution we get in the entire unit circle. It's one of the few times you only get one answer. Usually you have two quadrants that give you answers. But whenever you're dealing with one of these quadrangles, multiples of 90, you frequently only get one answer. Now, the other part is to let 3 sine t plus 1 equals 0, which means sine t equals minus 1/3. I don't know that angle, so that you're going to have to look that up on your calculator. And this time you need both the third and the fourth quadrant answers. Go ahead and look that up on your calculator real quick. What is t? You're taking the inverse sine of negative 1/3.
$19.47.
Is that what your calculator says?
Yep.
No, it doesn't. It should say negative.
Oh yeah, it
Did you
is
take the
negative.
inverse sine of negative 1/3, or did you take the inverse sine of 1/3?
No, it is negative. It says negative. I just didn't say negative.
So that's the fourth quadrant answer. In other words, that is an answer. T is equal to negative 19.7 degrees. But we also know sine is negative in the third quadrant. So what's the equivalent angle to that negative angle, which is in the fourth quadrant? You add it to 180, you get 199.47 degrees. In other words, if you put that into your calculator, what's the sine of 199.47? You should get negative 1/3, approximately. So your three answers to this problem are 90 degrees, minus 19.47 degrees, and 199.47 degrees. When's your test, Zach?
Tomorrow.
Tomorrow? Well, good luck. I feel like you've made some progress. Where you still need help is the further back we go. In other words, you seem to know calculus, and now you kind of know precalculus, and you know trig. It's when we get to the algebra that you have difficulties. This is all algebra here. Well, it's not quite all algebra, but it's mainly algebra. All right, I'll let you go. I'll talk to you next time.
Okay.
Good luck on your test.